the chemical reactions, right?
Okay.
Now understand. In chemical reactions, obviously, chemical reaction is basically what? A reaction
Yes.
in which something new is formed. Something new is formed. Yes or no?
Yes.
So how is it formed? When the old bonds break and new bonds are formed.
Okay.
Okay. So when old bonds break and when new bonds are formed, this would be called as a chemical reaction,
Oh.
right? So that means that you have a reactant. You have a set of chemicals which are reactants,
Mm-hmm.
and they would form a product. Okay.
Oh.
And obviously on the arrow is telling me the direction. Arrow is
Yeah.
telling me the direction of the arrow is telling me the direction of the movement of reaction.
After reaction. Yes.
Yeah. That means the reaction can go from reactant to product, and it is a
Mm-hmm.
unidirectional. If I get to see this kind of arrow, it would mean it is a unidirectional arrow.
Yeah.
I hope it would be a unidirectional arrow. Now, if I put it like this, that means it would be a reversible.
Directional.
Yeah, it's a bidirectional arrow. That means it would be a reversible reaction, provided the conditions remains the same, right? Under the same
Yeah.
conditions. Okay?
Okay.
Under the same conditions, right? So this is the reactant to product. All right. So you understand that whenever we are dealing with different kind of chemical reactions, you have to understand that what exactly is the condition required in those reactions. What
Yes.
happens when the products are formed, right? What
Yes.
happens? What kind of reactant does it take? How explosively that reaction will take place, or how slowly that reaction will take place, right? So,
Yeah.
if I give you this, let's say, okay, so there are different types of chemical reactions. Now, but understand, a chemical reaction is represented by a chemical reaction is represented by. I hope you're writing now. By
Yes.
a chemical equation. A chemical reaction is represented by a chemical equation, right?
Mm.
So when a chemical reaction is represented by a chemical equation, that means, let's suppose if I write down C plus O2, give me CO2. So what is a chemical reaction? A chemical equation is actually the representation of a chemical reaction.
Yeah.
So
So.
chemical reactions we perform in laboratory, and
Mm.
on the theoretically we write down that reaction or that change or the observation in the form of equation.
Yes.
That chemical
So.
equation,
Yeah.
yeah, tell me,
I'm just saying. So basically, what you perform is a chemical reaction that happens in the lab, and what you note down is the
is a chemical
chemical
equation. Yeah,
equation.
yeah.
Yeah.
So I can say it is a shorthand notation. It is a shorthand notation
Notation. Yeah.
of a chemical reaction. It is a shorthand notation of chemical.
Reaction.
Yeah. Right. So when it is a shorthand notation of a chemical reaction, it would be C plus O2 will give me CO2.
Mm-hmm.
Now the point here would be what? The point is that you have to make and you have to carry forward all the observations. So the equation, you have to make the equation informative.
Okay.
Okay. You have to make the equation informative. How would you make that equation informative? You would make that equation informative by, you would make that equation informative by writing down what? Either one, the states of the reactants, the state of the reactants and products. Okay, the states of the reactants and products.
1 second. States.
Yeah, like for example, if something I'm using which is in the solid state, that means some crystals or granules. So S would
Mm.
be representing as a solid state. If I have L, it would be the liquid state.
Okay.
All right. If I talk about aqueous, it will be the aqueous state.
Aqueous state.
Like aqueous means, let's say if I have some chemical which is in the solid state, let's say regular salt, and you dissolve it into water,
Mm-hmm.
and then when you dissolve it into water, then when you dissolve it into water, okay, that would be the aqueous state. Something which is dissolved in water is called aqueous state, and liquid state is also called as the molten state
Mm-hmm.
or the fused state.
Okay.
Are you understanding? So this would be the molten
Yeah.
state or the fused state. So we would have the solids, you would have the liquid state, you would have the aqueous state, right? So three states, and G would represent the gaseous state. So you
Yes.
have to mention the states. Let's suppose if I talk about the above equation, I would simply write it down like this. I would
Mm.
rewrite this equation like this. I would say carbon solid plus oxygen gaseous, arrow will give me carbon dioxide gas.
Mm.
Right? Okay, so this is one part. So how am I making the equation informative? By putting down the states. Now, second point, whenever, whenever the gas is formed, whenever the gas is formed in the product side, whenever the gas is formed in the product side, then, then whenever the gas is formed in the product side, then that
Okay.
component, then that component is represented by an upward arrow.
One
This one.
second. I'll just note it down.
Yeah. So CO2 shall evaporate and it is on the product side, provided the container is an open container.
Oh, okay.
Okay,
Well.
because if that also indicates that the container is an open container,
Mhm.
or you have opened the container in the end.
That's
Got the point?
one second. I couldn't understand component, so I thought it was compound. By an
Upward arrow.
upward, yeah.
By an upward arrow.
Yeah.
Right? So you would be representing it as an upward arrow.
And
Okay, so that is one part, right? So when you represent it with an upward arrow, so you would have this, right? Now, what is
mhm.
going to happen? Just see. So you are going to represent it with an upward arrow with an open container. So whenever the gas is formed, the product in the product side, that component is represented by an upward arrow. Okay. So
Oh,
let's suppose if I write down CH4, or let's suppose if I say some reaction, I would say Na2CO3. I will tell you how to frame this reaction, and then I write it down with HCl. So it would
mhm.
be NaCl plus H2O plus CO2, and I write it down in upward arrow. I said this is aqueous. This is aqueous. That means they're dissolved into water. This would also be aqueous. This is liquid, and this is gaseous. So I hope you're understanding this. CO2 shall evaporate.
Yeah.
So CO2 is shown with an upward arrow. Then we can also, third point, we can also represent, we can also represent the formation of a precipitate. We can also represent the formation of a precipitate by a downward arrow. Okay. We can also represent the formation of a precipitate by a downward arrow. What is a
Yes.
precipitate? A precipitate is a precipitate is an insoluble.
Okay.
Precipitate is an insoluble substance or product formed. It's an insoluble substance or product formed when a reaction takes place. Okay, it is an insoluble substance or a product formed when a reaction takes place. So that is basically a precipitate. I hope you're understanding. So we can also represent the formation of a precipitate by a downward arrow. All right.
I'll just
Then,
I'll just note down the formation of precipitate. 1 second.
so this was the upward gas, right?
Okay.
So to make the equation informative, that's very important that you write down each and every part of it. All right.
Yes.
This is right now 9 o'clock at your place. 9 to 10 slot.
Right now it's 10:30.
10:30.
Yeah, about 10:30.
Okay. 10:30 night.
Yes.
Oh.
Yeah.
Okay.
Yeah.
Now see. So it says it is an insoluble substance which is when the product is formed, when the reaction takes place. Got the point?
Yes.
Now just see. So whenever we are dealing with this insoluble substance, the product is formed and the reaction takes place. Now understand. Let's suppose if I am writing down a reaction AgNO3. So when I'm writing down AgNO3, it would be aqueous. And when you write it down NaCl, it would be what? Na plus and Cl negative.
Yes. Na
So we
plus
would
Cl
have
negative.
right. So we would have AgCl
Mm-hmm.
and we would have NaNO3. So AgCl shall settle down at the bottom, and this would be called as the precipitate. Are you
Okay.
understanding? This shall be called
Yes.
as a precipitate. Okay. So now this precipitate is nothing but just a solid.
Okay.
This is nothing but just a solid,
So.
right? So when we are talking about AgNO3 and NaCl, right? These two
Mm.
were two liquids or two substances which were soluble in water, right, Ariman? Like AgNO3
Yes.
would dissolve into water, right? NaCl would also dissolve into water, and they would form
Mm.
AgCl and NaNO3. Now, when they
Oh.
would dissolve and they would form NaNO3, okay, so you understand that one product is formed which is not dissolving in water. That means it's something like this. That we had let's say water, okay, and in
Oh.
this water, what are we going to do? We are going to add AgNO3 and we are going to add NaCl. And when we are going to add both of them, I am going to get AgCl and NaNO3. Now there is water. AgCl is not ready to dissolve into water. So that AgCl shall settle down. So that is called precipitate. So all of this. So basically you understand that when you have water, right? Ag plus and Cl negative would prefer to stay together and they would not dissolve into water. Dissolving into water would mean that Ag plus will separate and NO3 negative would separate. Na
Yeah.
plus would separate and Cl negative would separate. Na plus would separate and NO3 negative would separate. I hope you're understanding.
Yes.
So if the ions are separated, if in the picture the ions are seen separated, that would mean if in the picture the ions are seen separated, it would mean that these ions would be called as dissolved. If these ions are seen separated in water, okay, would be
Mm.
called as dissolved if these ions are seen as dissolved. Yes or no? But
Yeah.
AgCl, but AgCl would do what? We would have Ag plus and we would have Cl negative, and this
Mm.
AgCl would thereby form the precipitate. Are you understanding my point? Right? Because the
Yeah.
ions said to be the ions are basically sticking together and the ions are not separated. So that's
Yeah.
the basic idea, right? So for ions which do not separate, right? This is what the ions
Which.
do not separate.
Mm-hmm.
The ions which do not separate are basically forming a precipitate, and that is represented by a downward ion.
Okay.
Okay, so yeah, so this is basically a precipitate. Also, what do you represent on the chemical equation? Let's suppose I carry out a reaction A plus B. Let's suppose if I give you this reaction, I would say aluminium plus steam, and I would mention below 800 degrees Celsius.
Yeah.
So then Al2O3 would be formed. So I hope you're understanding that hydrogen gas shall be released. So you
Yeah.
understand that when we have Al plus H2O and Al2O3 plus H2 gas, I hope you're understanding that what kind of scenario do you think we have? We would have Al plus H2O will give me Al2O3 plus H2. Okay. We would
Yes.
have this. And the
Yep.
temperature here would be below 800 degrees Celsius and it would be Al2O3 plus hydrogen gas. So you understand that when we have this scenario, right,
Yes, ma'am.
what
Absolutely.
exactly is going to happen? Just tell me. So we would have aluminium plus H2O below 800 degrees Celsius. It would form Al2O3. So I am
Plus.
also mentioning the temperature.
Yeah, which is eight below 800 degrees
Yeah.
Celsius.
So this is basically called as what? Thermochemical equations.
Mm-hmm.
Thermochemical
Chemical equation.
equations. Why thermochemical equations? Because obviously it is chemical equation. That means I'm representing the chemicals, the reactants, and the products. But I am also representing what? I am also representing the heat and the temperature. So any
Oh,
reaction where you represent how much amount of heat is being absorbed or how much amount of heat is being released, such reactions are basically called as what? Thermochemical
thermochemical
reactions.
equation.
Yes. Because so basically the reactions where heat or temperature, heat energy value, okay, heat energy value or temperature is mentioned
Is
are called,
thermochemical.
yeah, are called thermo.
Ma'am, what's the second word? The.
This is a short form for reactions, RXN.
Okay. The reaction. The
Where,
reaction.
where heat
Yeah.
energy value or temperature is mentioned are called as
Mhm.
thermochemical.
Yeah. And
You understand?
yes, ma'am. One sec.
So,
Yeah, I'm done.
okay. Now, so thermochemical reactions are divided into two types. Thermo are of two types. Thermochemical reactions are of two types. The first type is endothermic reactions.
Mm-hmm.
The endothermic reactions. And the another type would be the exothermic.
Reaction.
Yeah. So you have to understand that when we have the endothermic reactions and when we have the exothermic reactions. So in the endothermic reactions, what exactly is going to happen? That whenever you perform a reaction in the beaker, the final products that are being formed, it is basically cooled down. So basically the temperature of the beaker falls down and the beaker becomes cool. So if we get a cooler beaker after the at the end of the reaction, at the at the end of the reaction. All right. If we
Mhm.
get a polar beaker at the end of the reaction, it would be called as an endothermic. So basically, this is the indication. Sometimes question says that we do not know whether that reaction is endo or exo. I would simply say that you carry out a particular reaction, right? So it would be called as it would be called as an endothermic reaction. So you just touch the boundary of the beaker, right? It would be called as a
Endothermic.
endothermic
If you
reaction.
endothermic reaction is when you get a cool beaker at the end of the
Yeah,
reaction, and
yeah,
exothermic is when
that
you
is
get a hot
hotter
hot
beaker. Yeah.
hot
So
beaker.
point here is that this is a physical appeal, physical touch method, right? So just by
Yeah.
seeing or just by touching the beaker, you can identify. But there's a very different way of writing it down also, right? So when we're talking about the exothermic reactions, so what is it? The beaker becomes hotter
Yeah.
after the reaction. The beaker becomes hotter. Now understand one thing that the kind of chapter this would be a little bit lengthy chapter. Why? Because this will be the base for all the other chemistry chapters.
Yes.
Okay. Here you would understand how to frame the reactions. After that, it would be very easy for you to understand. There would be logics, of course, but the equation formation comes from this chapter. Okay. So you
Yeah. Okay.
understand that when we are talking about the exothermic reaction, so how do we write it down? The method of writing down the exothermic reaction is that A converts to B and releases a lot of heat.
Mhm.
So we write down the value of heat. Let's say I say A gives me B plus 2000 joules, kilojoules of energy.
Okay.
So kilojoules is the unit of heat.
Energy.
Kilojoules is the unit of heat, right, Aryan?
Mm-hmm.
Okay. So kilojoules would be the unit of heat. Any doubts in this?
No.
All right. So this is a basic part that kilojoules would be the unit of heat and A would convert itself into B plus 200. Are you understanding?
Yes.
All right.
Mm.
And for endothermic, you have to provide heat to the reactant and then B shall be formed. Okay. You have to provide heat to the reactant
Heat to
and
the
then
reactant.
B shall, yeah,
Yeah,
heat to
reaction.
the reactant and then B shall be formed.
Okay.
Right.
Yeah, I'm
So
right.
that's
Yes.
the way. Also, another way of writing down an exothermic. Now, if I bring this heat here, just like I do transposing in maths, so this would become A minus heat would also give me B. And I
Mm.
can write it down as A plus B. A gives me B minus heat. So I would have A will give me B minus heat. Okay, that's the point. Got the point?
Mm. Yes.
So this is very different way of writing down a particular reaction. Okay?
Okay.
All right. So these are thermochemical reactions. So this is all that you can represent with a chemical reaction. Or also what you can represent? The formula for reactants and products. The formula for reactants and products. Okay? That would be what? The formula for reactants and products. That would be what? It would be,
Ma'am, can you repeat what you just?
yeah, I'm saying, let's suppose if I write it down CaCO3 and on heating it would form CaO and CO2. So
Yeah.
I am simply saying that CaCO3 on heating will give you CaO and CO2.
Plus.
So what
Yeah.
is CaCO3? That's limestone.
Yeah.
So I am saying that you have the formula for CaCO3. I am
Mm-hmm.
saying quicklime. So there would be the formula of CaO, right? I would be saying there would be CO2. So that means this is a formula of carbon dioxide.
Yeah. So, oh, the
Rather
form
than
you
writing
so
it, yeah.
You're asking for the formula of reactants and products for
Yeah, I'm
reactants.
not asking. I'm saying the equation also tells me the formula of the reactant.
Yeah, it's a reactants to products.
Yeah.
So it converts.
Hmm. And rather than writing down carbon dioxide, I would simply say what? I would simply say CO2.
Yeah.
Yes or no? So rather than saying carbon dioxide, I would simply say it would be CO2. Rather than saying quicklime, I would say CaO. All right.
Yes.
So quicklime, basically, this formula is basically a shorthand notation of the compound, right? So that's what you're supposed to understand. So we would have CaCO3 would give me CaO and would give me CO2. Any doubts in this? Are you sure?
Yes.
This would give me CaCO3 to CaO plus U.
Okay, actually, I have one question. Can products turn out also go back as reactants?
Yeah.
As you know,
If they do,
they,
it would be then called as a reversible reaction.
okay.
Yeah. If they do not, then it would not be called as a reversible reaction. Got the point?
Yes.
So then CaCO3 would give you what? CaO plus CO. That's the point. Got it? Now, next, what do we have in here? Just got the point?
Yes.
Okay. Now you understand. So we would have CaCO3 to give me CaO and CO2.
Mm.
Okay. This is one part. Now, there is a point that what information can a chemical equation not represent? So now all of this a chemical equation can represent. What information can a chemical equation not,
Not repressed.
yeah, not represent? Now, one is the speed of the reaction.
Okay.
Because obviously when I write down a certain reaction, if I say that Na reacts with water to form NaOH, NH2 gas. Now, this reaction seems to be pretty normal on the screen or on the paper, but if you
Mhm.
really carry out this reaction, this is actually an explosive reaction. It would not even take fraction of seconds and it would just explode.
Okay.
You understand? So it would not even take more than fraction of a second and it would simply explode. What
Okay.
exactly does that mean? So that means with this reaction written on the screen or on the paper, you cannot tell that whether this is going to carry out a further reaction or whether there would be explosion or not. Na will combine with water to form NaOH
Mhm.
and hydrogen gas shall be released.
Yeah.
You understand the point?
Yes, I'll just note it
Got the
down.
point of it.
I'm
So
so I have one more doubt. What are all the what are all the information that a chemical equation cannot represent? Is it only speed of reaction?
one more thing I'm coming to. So it is the speed of the reaction, right? That means whether the reaction is slow or fast
Mm-hmm.
or explosive,
Yeah.
we do not know. Understood my point?
Yes.
So that is about the speed of the reaction. That is about the speed of the reaction. Now, the second part that we have here is the feasibility of a reaction. The feasibility of the reaction. So when
So
we are talking about
how
the
accurate
feasibility,
it
yeah,
is? What is the
No.
success rate?
Yeah, feasibility means that if I write down a certain reaction, let's say if I write down Cu plus FeSO4, and I have very confidently written down CuSO4 plus Fe.
Mm-hmm.
So if I have very confidently written down CuSO4 plus Fe, you understand?
Yeah.
And hence we would have this.
So one is
Now
speed of
this
the
reaction
reaction.
in reality, this reaction in reality does not even happen. So feasibility
Mm.
would mean whether that reaction shall originally or in real times will that reaction actually take place or not. So whether,
Yeah, it would work out
yeah, whether that reaction will occur
or not.
in reality or not. All right. So this is
Mm.
basically the feasibility of the reaction.
1 second, I'm just noting it
All
down.
right. Yeah.
Yeah, I'm done.
Got it. So whether that reaction will occur in reality or not is basically what is the feasibility of reaction. So two things you cannot identify by looking at a particular reaction. Now,
Yeah.
the next is, so this is all about the types of chemical reactions we have. So now the point comes is that, okay, if we have a chemical reaction, we got to make that chemical reaction as possibly as informative. Also, one more thing. Let's suppose if I write down this reaction, CO2 plus
Mm-hmm.
ammonia, and it would form NH2CONH2. You understand? So what
Yeah.
exactly is going to happen with CO2 if I put an upward arrow here? So this is wrong. Totally wrong. Why this is totally wrong? Why this is totally wrong? Because see, understand, if in the beaker you're putting up, you have a beaker, right? And you have CO2, and that CO2 shall evaporate. So if you really evaporate that CO2, what exactly is going to happen? Just tell me. If you evaporate that CO2, what exactly do you understand from this part? That whenever you evaporate CO2, okay, so CO2 shall evaporate, and
Yeah.
one of the reactants is gone. Are you understanding?
Oh,
So putting up an
yes.
upward arrow would mean that one of the reaction is actually gone. How is
Oh,
that even possible? How is that even possible? Just tell me. You understand?
that's
Like a reaction cannot happen without the two reactants. You need two reactants, so you need the reactant. And obviously, if the reactant is gaseous, and let's say on the reactant side you put this upward arrow, that means you're saying that CO2 gas in the reactant is escaping out. That means a forward reaction will not take place. So
yeah.
that means this upward sign, that means the reaction, before the reaction has taken place, the reactant has been eroded. So this upward sign does not or can't be used, upward sign can't be used in reactants. All right. So the upward sign can't be used in the reactants. Any doubts in this?
No.
Okay. So this upward sign can't be used in the reactants. Right.
Yeah.
All right. Got the point?
Yes.
Right. So this upward sign has to be used in the product side only. That's important. Next, what do we have? Okay, this is it. So that's what we basically have. So we would have an upward sign which can't be used in the reactant side, and this is what we have. All right, that's one very important point. Now the point is to remember a particular or to make a particular equation, you should know a list of radicals. Okay, write it down. You should know a list of radicals. So when you should
Yeah.
know the
Can you
radicals, sorry,
repeat it again? A list
I'm
of
saying,
radicals.
yeah, I'm saying to write down a particular reaction, you must
To
learn a list of radicals, or you also call it as a polyatomic ion. You should know the names of these polyatomic ions, right? So let's suppose I would have Cl minus 1. I would have Br minus 1. I would have I minus 1. I would have F minus 1, right? I would have OH minus 1. I would have O minus 2. So we
yeah.
would have chloride,
Mm-hmm.
we would have bromide, we would have iodide, we would have fluoride,
Bromide, iodide.
we would have hydroxide, we would have oxide,
Mm.
right? So we would have chloride, we would have bromide, we would have iodide, we would have fluoride, we would have hydroxide, we would have oxide. The names of these ions you should know. N minus 3 would be called as nitride. S minus 2 would be called as sulfide. P minus 3 shall be called as phosphide.
Okay.
So we would have nitride, sulfide, and phosphide. Okay, nitride, sulfide, and phosphide. So that's what we will be there. So it will be called as nitride, sulfide, and this will be P minus 3. And this shall be called as phosphide.
Okay.
So we would have chloride, we would have bromide, we would have iodide, we would have fluoride, hydroxide, oxide, nitride,
Mm-hmm.
sulfide, and phosphide. Okay,
Yes.
so that's what we have. Now we would have this one, right? Any doubts? Then we would have what? So these are basically all ions.
Yes.
Ions would mean the single atoms carrying charge.
Okay.
I will explain it to you how these charges basically came. But ions would mean single atoms carrying
Mm-hmm.
a charge. Let's suppose if I say, so these are all negative ions, right? So I would say these are all anions. Written down?
1 second, I'll be right. Yeah.
Alright? So single atoms carrying a charge.
Are called ions.
And negative charge, anions would mean ions carrying negative charge. Alright,
Okay.
ions carrying negative charge would be negative charge ion.
Mhm. Ions. Um, So do all ions carry negative charge? No, right?
No, few carry positive charge. If they carry positive charge, they would be called as cation.
Cations and anions.
Yeah.
So cats, K, charm, ions.
So cations would mean, let's say if I say Na plus, Li plus.
Mm.
So this is beryllium ion, magnesium ion, calcium ion, strontium ion, barium ion. So in case of positive ions, you have to write down the names along with ion. So this would be called as a sodium ion.
Mhm.
This would be called as a lithium ion. This would be called as a potassium ion. This would be called as a rubidium ion. And this would be called as a cesium ion. Are you understanding? Are you understanding?
Yes.
This would be beryllium ion. This would be magnesium ion. This would be strontium ion. This would be barium ion. Are you
I'm
understanding?
sure write these down.
Yeah, yeah.
Okay.
Zinc was always +2. So you always remember that these would be the constant charges that these atoms would carry. This would be
Mhm.
zinc ion. So these are the charges which are constant. Ag will become Ag plus. So you will say silver ion. Now, how did this atom basically gain this particular charge? We'll discuss it. But I hope you're understanding that this would be the case of cation.
Yes.
Okay. Now, also you have to understand that when we have sodium ion, beryllium ion, magnesium ion, all of it, then we have some ions carry double valencies.
Carry
Some
double
positive
one.
ions carry multiple valencies. And when some positive ions carry multiple valencies, what would that mean? Some positive ions would carry multiple valencies. Now, what would that mean? Just understand. So let's say if I say Fe plus 2, and then it would be Fe plus 3, Pb plus 2, and then it would be Pb plus 4. We would have Au plus 1, and we would have Au plus 3. We would have Cu plus 1, and we would have Cu plus 2. We would have Sn plus 2, and we would also have Sn plus 4. Yes or no?
Mm.
This would be plumbous, and this would be plumbic. This would be aurous, and this would be auric. This would be cuprous, and this would be cupric. This would be stannous, and this would be stannous. Okay, stannous ion and stannic ion. So basically, the name which ends with ic, the names which end with ic, they ic represents higher valency,
Okay.
and us represents lower valencies. So ic would represent a higher valency, and us would represent a lower
Lower
valency.
valency.
Yeah. So this is what you have to understand, that ic would represent a higher valency, and us would represent a lower valency. So
Yes, sounds
everywhere,
good.
so aurous, it would be aurous ion, it would basically be Au plus 1, and auric would be Au plus 3. Fe plus 2 would be ferrous ion, and Fe plus 3 here would be ferric ion.
Mhm.
All right. Pb plus 2, less valency, plumbic would be higher valency. Got the point or not?
It gets higher and us is lower.
Yeah, ic is higher and us is low.
Yes.
All right. So this would be ferrous and this would be. Got the point?
Yes.
So these are certain ions, positive ions that we are talking about. Next, we would have the radicals or the polyatomic ions. The polyatomic ions are basically also called as radicals. All right. And it would mean what? That the group of atoms carrying a charge, either positive or negative. The polyatomic ions are basically a group of atoms carrying a certain charge, which would be either positive and which would either be negative, right?
Yeah.
So let's suppose we would have NH4 plus. So basically what is happening, there are a group of one nitrogen and four hydrogens together would carry a plus one charge, and hence it would be called as ammonium ion. All
Okay.
right, do you understand my point? So
Yeah.
when I say PH4 plus 1, it would be called as phosphonium.
First, plasmonium ion.
Yeah, got the point. So we would have the ammonium ion and we would have the phosphonium ion.
Ion.
Okay, we would have the ammonium ion and we would have the phosphonium
Ion.
ion. Got the point? So
Yes.
similarly, if I have this is one part, right? So let's suppose if I say SO3 minus 2, SO4 minus 2, SO5 minus 2, S2O3 minus 2. So I would have what? We would have sulfite and we would have sulfate and we would have persulfate
Okay.
and we would have thiosulfate. Are you understanding? These are
Mm,
radicals. These are negative radicals. So let's suppose if I say NO2 negative and if I say NO3 minus 1 and if I say NO5 minus 1. So this would be nitrite and this would be nitrate and this would be pernitrate.
yes.
This would be pernitrate. I hope you're understanding.
Mhm.
Similarly, if I'm writing down CO3 minus 2, it would be carbonate.
Yeah.
It would be a carbonate radical. You understand? And if I
Yes.
write it down CO4 minus 2, it would be a percarbonate. Correct? Got the point?
Yeah.
Now we would have what? Now we would have, let's say, MnO4 minus 1, and we would also have MnO4 minus 2. So MnO4 minus 2 would be called as what? Manganate,
Manganese.
right? And this would be called as permanganate. This shall be called as permanganate.
Yeah.
All right. So this shall be called as permanganate, and this is manganate. Then we would have CrO4 minus 2. So that would be called as chromate. And if we have Cr2O7 minus 2, this shall be called as dichromate.
Mhm.
So this would be CrO4 minus 2. and this would be permanganate.
Yeah.
All right.
Yeah.
So we would have permanganate, we would have manganate, we would have chromate, and we would have dichromate. Are you understanding?
Yes.
So this is the part. So we would have permanganate, we would have manganate, we would have chromate, and we would have dichromate. So these are
Mhm.
the ions, right? Now, what other possible ions we could have? We would have arsenate, ASO3 minus 3, and we would have
Yeah.
ASO4 minus 3. So this would be
Oh,
arsenite, and this would be arsenate. So we would have arsenite and we would have arsenate. Understood my point?
mm, yeah.
Okay. So this is the radical that we have, right? Then, okay, so we would also have ClO4 minus 1. We would
Mhm.
also have ClO3 minus 1. We will have
Mm,
ClO2 minus 1. We will have ClO minus 1. So this is called as perchlorate. This
yeah.
would be called as chlorate. This would be called as chloride. And this would be called as hypochlorite.
Okay.
Correct? Similarly, we would have BrO4 minus 1, BrO3 minus 1, BrO2 minus 1, and we would also have BrO minus 1. So I hope you're understanding.
Yeah.
We would have perbromate, we would have bromate, we would have bromite, and we would have hypobromite.
Okay.
So we would have bromite, we would have hyperbromite, we would have bromate, and we would have perbromate.
Yeah.
Are you understanding?
Yes.
Got it?
Mhm.
That is one part. So we would have perbromate, we would have bromate, we would have bromide, and we would have hypobromate. We would have
Yes.
perchlorate, chlorate, right? Similarly, we would have IO4 minus 1. This would be behaving like this would be periodate. This would be iodate. This would be iodide. And this would be hypoiodide.
Okay. Ma'am, a question. How many classes do we have per week? So like
5.
on which days?
Monday to Friday. And if need be, Saturday, Sunday also.
Okay.
All right. So this
Yeah.
would be hypoiodide. Right. These are the certain radicals that we have.
Yes.
Then we would have ZnO2 minus 2. This is called zincate.
Mhm.
This is called zincate.
Yeah.
Then we would have, okay, this is zincate. Then we would have AlO2 minus 3. This would be aluminate. And we would have AlO2 minus 2. This would be metaluminate. This would be metaluminate. This is aluminate and this would be metaluminate. This would be zincate, aluminate, and metaluminate. Got it? Right. Then we would have SnO4 minus 2, SnO3 minus 2. So this is basically stanite, and this would be stannate. We would be talking about plumbus. So we would have PbO2 minus 2. This would be plumbate.
Yeah.
All right. So yeah. Then we would have Cn minus 1. This would be cyanide. Now, for now, I don't know if you would be given a list, right? So you can keep this list as handy with you if you are allowed to see the list, and otherwise you will have to learn it. Now,
Okay.
it depends upon whatever is the requirement in school, but I am giving you a comprehensive list of all the possible radicals you will find in 10 different books. You don't have
Yes.
to worry about that because as much as I know the pattern, they would give you a topic, but the questions that come in the paper, they're kind of interrelated, right? So
Mhm.
I had basically 4 to 5 kids, right, earlier, like last year. And what happened was that there was this chapter of linear equations, or sorry, chemical equations. And when I really saw the questions were basically application based.
Okay.
And when the application based questions, they had given questions which would definitely involve the concept, but it would involve the reaction from different aspects of the chapter. So some parts of it would require some other chapter's information. So what is this chapter is important that we need to know each and every reaction in detail.
Okay. Yes,
So
ma'am.
that whenever any kind of question that comes up, you're able to identify that, okay, this is this part and this is that part. So that is very important. You understand? So we would have periodate, we would have iodate, we would have iodide, and we would have hypoiodide. Are you understanding?
Yes.
So this would be plumbate, cyanide, cyanate. Then we would have, write it down, SCN. This would be thiocyanate. Right? This would be thiocyanate.
Ma'am, ma'am, can I go to the wash?
Yeah. The class is just done.
Yeah.
All right. So we'll
I'll
write
go.
down the remaining in the next class.
Yes.
That's it. All right. Thank you. Bye.
Thank you, ma'am.